Amazon Fire Phone in 2014. Amazon launched the Fire Phone to challenge the Apple and Samsung duopoly. Far more than a phone, it was envisioned as a mobile portal to Jeff Bezos's retail empire. It featured a Snapdragon 800 quad-core processor at 2.2 gigahertz and 2 gigabytes of random access memory. While these specifications matched high-end flagships, the device's true ambition lay in its unique sensor architecture. The hardware utilized 4 specialized front-facing infrared cameras to power a system called dynamic perspective. This array tracked the user's head position to render a pseudo 3D effect on the 4.7-inch 720p display. To sustain these visuals, the graphics processor had to recalculate interface depth at 60 frames per second constantly. This process consumed significant battery life and processing cycles for a feature that many users found to be a mere visual gimmick. The nightmare intensified with Fire operating system, a restrictive software environment lacking the Google Play Store and essential apps like YouTube. Amazon instead pushed Firefly, a tool designed to scan real-world objects for instant purchase on their platform. This aggressive integration of commerce over utility led to a massive $170 million write-down in unsold inventory. Consumers ultimately rejected the 5.6-ounce device, as it prioritized being a shopping scanner over a functional connected smartphone. Windows 8. In late 2012, Microsoft released Windows 8, an ambitious software experiment that attempted to unify the traditional desktop and mobile tablet experience into a single cohesive architecture. The company's vision was built heavily on the Metro design language, abruptly replacing the beloved Start menu with a full-screen grid of live tiles. This new interface was optimized primarily for touchscreens, but for the hundreds of millions of people using a standard mouse and keyboard, it felt like navigating through a confusing digital maze. Microsoft effectively alienated its core enterprise and power user base by forcing a rigid tablet-first workflow onto high-performance workstations, causing a massive stagnation in hardware upgrades and PC sales worldwide. Technically, Windows 8 introduced some solid under-the-hood improvements, such as native support for unified extensible firmware interface and the debut of the Windows Store for centralized software distribution. However, the dual interface system led to a jarring user experience where some critical settings were in the new PC Settings app, while others remained buried deep within the old control panel. The system struggled significantly with application compatibility on its ARM-based version, Windows RT, which unfortunately could not run traditional 32-bit or 64-bit desktop programs. This widespread confusion resulted in Windows 8 capturing less than 15% of the total market share years after its release. As users desperately chose to stick with the stability of Windows 7, 3D TV, the early 2010s saw the entire consumer electronics industry bet their future on 3D televisions, a trend sparked by the massive cinematic success of high-budget blockbusters. Manufacturers like Samsung, Sony, and LG rushed to market with displays featuring high refresh rates of 240 Hz to handle the synchronized shuttering required for the effect. Most systems utilized active shutter technology, where bulky, battery-powered glasses flickered at high speeds to trick the brain into seeing depth. This forced hardware requirement created a miserable user experience, characterized by significant dimming of the screen brightness and a visual phenomenon known as crosstalk, where ghosted images would cause severe eye strain and headaches after just 30 minutes of viewing. Beyond the ergonomics, the technology suffered from a catastrophic lack of content and connectivity standards. Broadcasters found that filming in 3D required specialized camera rigs that were twice as expensive and required massive amounts of bandwidth for transmission. While a standard high-definition signal was manageable, streaming or broadcasting 3D content demanded advanced compression that often degraded the resolution to subpar levels. Despite the marketing hype, by 2016, major manufacturers stopped producing 3D panels entirely. Millions of consumers were left with expensive displays that had a premium feature no one wanted to use, proving that adding a dimension couldn't save a product that lacked comfort and convenience. Apple Butterfly Keyboard. Apple's obsession with extreme thinness led to a hardware design flaw so fundamental that it compromised the reliability and reputation of their entire MacBook lineup for nearly half a decade. In 2015, the company introduced the butterfly switch mechanism, deliberately replacing the industry-standard traditional scissor switch design. This new architecture reduced key travel to a mere 0.5 millimeters, allowing for a much thinner chassis but significantly sacrificing the deep tactile feedback that professional users expected. The nightmare began when owners realized that the extremely low-profile design left absolutely no room for error. The smallest speck of common household dust could wedge itself under the keycap, rendering it completely unresponsive or causing it to register a single press multiple times. Engineers desperately tried to iterate on the troubled design through 3 different generations, even adding a thin silicone membrane in 2018 to act as a primary debris shield. However, the fundamental physics of the switch remained fatally flawed, as it lacked the necessary clearing force to push out microscopic particles once they entered the mechanism. This led to a massive $50 million class action settlement in the United States and a costly worldwide repair program that drained Apple's resources in both logistics and brand loyalty, despite being a trillion-dollar leader in computing systems. Apple was eventually forced to admit defeat and revert to the older, more robust Magic Keyboard design in late 2019. Juicero. In the world of over-engineered tech, Juicero stands as the undisputed champion of solving a problem that never existed. This Silicon Valley startup raised over $120 million in venture capital to build a Wi-Fi connected juicer with an initial retail price of $400. The machine was a beast of industrial design, containing over 400 custom-engineered parts, including high-grade aircraft aluminum and a press capable of generating a staggering 8,000 pounds of force. Its primary function was to squeeze proprietary QR-coded pouches of pre-chopped fruits and vegetables, ensuring that only authorized ingredients could be processed by its connected computing system. The complexity was staggering for a simple device meant for a kitchen counter. Featuring high-speed connectivity to check expiration dates via a cloud database before every single squeeze cycle. But the high-tech facade crumbled instantly when a Bloomberg report revealed a humiliating truth about the product's core functionality and engineering necessity. Despite the massive 4 tons of pressure generated by its expensive internal motors and complex gear systems, a human being using their bare hands could squeeze the pouches just as fast and extract almost the exact same amount of juice. This revelation turned the $400 appliance into an overnight laughingstock, leading to the company's total collapse and liquidation within mere months of the news breaking. Humane AI Pin and Rabbit, A1. The year 2024 marked a frantic and premature rush to kill the smartphone. Led by 2 highly publicized AI-native devices, the Humane AI Pin and the Rabbit R1, these gadgets were marketed as the next definitive leap in computing systems, utilizing large language models to replace traditional screens with voice and vision-based interactions. The Humane AI Pin, a $699 wearable, featured a specialized laser ink display that projected interface information directly onto the user's palm. However, the hardware suffered from severe thermal throttling issues, with the device often reaching internal temperatures that felt like 110 degrees Fahrenheit against the user's chest during basic operation. This rushed launch resulted in a nightmare user experience where the primary interaction involved waiting several painful seconds for a cloud-based response, only to receive bizarre hallucinations or flat-out incorrect information. Similarly, the Rabbit R1, priced at $199, promised a revolutionary large action model to automate complex app tasks through a simple handheld interface. In reality, the device was plagued by extreme server latency and a disappointing battery life that struggled to last even 4 hours on a single charge. Both products demonstrated the dangerous gap between aggressive marketing hype and the current limitations of mobile processing power and connectivity bandwidth, proving that AI is not yet ready to live independently outside of our phones. Google Glass. Google Glass was supposed to be the pioneer of augmented reality, a lightweight optical head-mounted display designed to put the internet directly in your line of sight, released in 2013 for $1,500. The device utilized a tiny prism display to project a high-resolution floating screen equivalent to a 25-inch monitor viewed from 8 feet away. It featured a 5-megapixel camera capable of capturing 720p video, all powered by a custom computing architecture tucked into the frame. Despite its technical sophistication, Google Glass failed to account for the most critical factor in consumer technology: human psychology. The presence of an always-ready camera created an immediate atmosphere of suspicion in social settings, as bystanders had no way of knowing if they were being recorded. This privacy anxiety led to the device being banned from restaurants, movie theaters, and casinos across the United States almost instantly. Users wearing the headset were mocked with the derogatory term glassholes, and reports of people being physically harassed for wearing the tech became common. Ultimately, Google Glass proved that no matter how advanced your head-up display or connectivity bandwidth is, a product will inevitably fail if it violates the fundamental social contracts of privacy and etiquette. Apple Maps in 2012. Apple made a bold but disastrous move to replace Google Maps with its own proprietary navigation service in iOS 6. The software was powered by advanced vector-based graphics that promised smoother zooming and faster rendering. But the underlying geographical data was a mess of epic proportions. Users quickly found famous landmarks displaced by dozens of miles, and the satellite imagery often depicted world-famous bridges as if they were melting into the ocean. However, the situation shifted from comical to life-threatening when the navigation system began directing travelers into the heart of the Murray Sunset National Park in Australia. Local authorities had to issue an emergency public safety warning after several motorists were stranded in the scorching wilderness for up to 24 hours without food or water. Following directions that placed a major city in the middle of a desert, with temperatures in the region soaring to 114 degrees Fahrenheit, the digital glitch became a real-world survival nightmare for those relying on their smartphones. This failure forced an unprecedented public apology from Tim Cook, who suggested that Apple users should download competing apps like Google Maps while his engineers spent years rebuilding the platform's core connectivity, cloud infrastructure, and data accuracy from scratch. GoPro Karma drone. The launch of the GoPro Karma was supposed to be a triumphant expansion for the action camera giant, but it quickly turned into a literal rain of falling debris that threatened public safety worldwide. Released in late 2016 for $799, the Karma featured a sleek foldable design and a removable 3-axis stabilizer. It utilized a high-bandwidth digital transmission system to stream live video back to the controller from thousands of feet away. However, a catastrophic mechanical flaw existed in the battery latch mechanism, which failed to hold the heavy battery pack securely during high-intensity flight maneuvers or even minor vibrations. This caused the drone to lose all power instantaneously while hovering at altitudes of over 100 feet. The result was a series of terrifying incidents where 2-pound drones suddenly became unpowered projectiles, falling freely toward the ground without any emergency failsafe. GoPro was forced to issue a total recall of all 2,500 units sold just 16 days after the official launch. The company's stock price plummeted as videos surfaced online showing the Karma falling like a stone out of the sky, narrowly missing people and property. This massive engineering oversight proved that in the world of computing and robotics, a simple physical latch is just as critical as the most advanced flight control software, especially when a failure means a heavy object dropping onto someone's head. Samsung Galaxy Note 7. In 2016, Samsung tried to cram a massive 3,500 mAh battery into a chassis so slim that it left almost no room for the components to breathe. This engineering gamble created a physical pressure cooker inside the phone, where the positive and negative layers of the battery were squeezed together with a margin of error smaller than a human hair. The world watched in total chaos as Note 7 units transformed into literal pocket bombs, exploding in hotel rooms, setting Jeeps on fire, and forcing the Federal Aviation Administration to ban the device from all flights under threat of federal prosecution. Images of charred nightstands and melted smartphone shells flooded social media, creating the worst public relations nightmare in the history of mobile computing. Samsung had to issue an emergency recall for over 2.5 million devices, eventually sending out fireproof return boxes lined with ceramic fiber to prevent further explosions during shipping. This disaster resulted in a staggering $5.3 billion financial hit and forced the company to implement an 8-point battery safety check that remains an industry standard today. It was a brutal lesson for the entire tech world when you push energy density too far without a safety buffer. Your flagship product becomes a high-tech fire hazard. Theranos and the Edison machine. The final nightmare on our list isn't about a glitchy screen. It's the story of a $9 billion empire built on a lie called the Edison machine. Theranos claimed this small box could perform over 200 medical tests using just a single drop of blood. Roughly zero point zero 0.01 fluid ounces, taken from a finger prick. This promised to replace the massive lab machines that usually require multiple vials of blood and professional needle draws. However, the reality inside the box was a mess of broken glass and leaking fluids, as the miniature robotic arms frequently crashed into each other while trying to handle the samples. Because the tech simply didn't work, the company secretly ran patient blood through traditional, full-size machines from competitors, diluting the tiny samples just to get a reading. This scientific fraud led to thousands of people receiving terrifyingly wrong medical data, including false reports of heart attacks, HIV infections, and even miscarriages, directly endangering human lives for the sake of a high-tech fantasy. When federal regulators finally raided the labs, they found that Edison's accuracy was so poor it failed to meet basic safety standards for almost every test it performed. The company's total collapse and the subsequent prison sentences for its leaders serve as the ultimate warning in technology. Faking it can be a billion-dollar crime when the cost is measured in human life.